Don't forget to subscribe and press the bell icon to never miss a video from testbook.com.
Hello guys, I'm Dhiraj and I welcome you all on the testbook.com, and I'm here to provide you the best I have. So guys, once again, I'm in front of you with another session on what previous year question for gate mechanical, right? So we are going to discuss about the thermodynamics question, right? So I can see that few people have already joined. So guys, those who have already joined, they have to do hit like, share and subscribe the session. And my dear, you have to share the link of this video in your social media group so that your friends will get benefited of this session, right? Okay, so guys, right now it's 2:58, so we are going to start the session within 1-2 minutes. Okay, 1-2 मिनट में हम लोग जो है शुरू कर देंगे, and then my dear will solve the different varieties of question based on what, my dear, gate mechanical for thermodynamics. Okay बच्चा party. And one more thing that I want to add, that people, those who have came first time in this channel, that I want to let you know, my dear, that there is gate exam festival going on, and just because of that we are giving Testbook Pass just for rupees 299, my dear, and you are getting 100 plus courses and, my dear, 12,000 plus tests in that Testbook Pass. That is a single pass for multiple examinations. It covers all the examinations like defense, technical, non-technical, SBI, banking, teaching. Every exam has been included in this, and you can also attempt the mock test which is available in the website as well as in the app. That will be free of cost. And my dear, one more thing that I want to add, you can also explore, that is SSC JE mechanical live coaching demo in preview classes which are available free of cost in the website as well as in the app. And if you are interested in it, my dear, then you have to fill the application form, and the link of that application form has been provided in the description of this box. Okay, and my dear, you are getting gate mechanical live coaching just for rupees 4,000 approx. And my dear, in that you are getting live classes, you are getting PDF notes, you are getting doubt sessions, and you'll get personal coach as well. Okay, so you can explore the demo classes of the gate mechanical in website as well as in the app, my dear. Okay, so guys, these are the various offers and opportunities for you guys by the testbook.com. Okay, so guys, get benefited of this opportunities, and if you have already benefited, my dear, then tell your friends as well. अपने दोस्त भाई बहन को भी बताएं आप. Okay, so guys, we are going to begin now. So right now it's 3 p.m. so guys, we are going to begin. ठीक है, so बच्चा party, here we go, my dear. चलें. So this is the first question on your screen. This one, see, my dear. A calorically perfect gas, specific heat at constant pressure is what, my dear? 1000 joule per kg Kelvin. Okay, Cp is given. It is what, my dear? Cp, right? Enters and leaves gas turbine with the same velocity. Okay, the temperatures of the gas at turbine entry and exit are 1100 Kelvin and 400 Kelvin respectively. The power produced is 4.6 megawatt. Okay, work done, right? The heat escapes, that means escape means what, bacha? Escape means rejected. That you have to decode the terms, then and only you are able to identify the correct data. Otherwise you took it as what? Heat supplied, then your answer will be wrong. Okay, escape means that is a heat rejection is there at the rate of 300 kilojoule per second. क्या रेट से इंडिकेट बाहर जा रहा है? 300 किलोजूल पर सेकेंड, एंड दिस इज नथिंग बट व्हाट बच्चा? किलोवाट. किलोजूल पर सेकेंड मींस through the turbine casing. Okay, the mass flow rate of the gas in kg per second through the turbine will be. क्या पूछा है हमसे? हमसे mass flow rate पूछा है बच्चा पार्टी. Okay, क्या पूछा है हमसे? They have asked mass flow rate. Okay, so my dear, how we can calculate? We can just go through what, my dear? हम लोग सीधे लगाएंगे क्या लगाएंगे बच्चा? Yes, we can apply the steady flow energy equation because it's a turbine and it is what, my dear? Open system. Okay, so bacha party, here we go. You know that steady flow energy equation, and that is what, my dear? Mass flow rate multiplied by h1 plus v1 square by 2 plus gz1 plus capital Q. Okay, sometimes it is small q. Small q means what, my dear? Capital Q divided by mass, that is heat per unit mass. Okay, that is also known as heat flux. specific. And my dear, see, now we have mass flow rate again, and that will be what? H2 plus V2 square by 2 plus GZ2. That is kinetic energy and potential energy plus W, right? My dear, you know that here this will get cancelled out, right? Potential and kinetic energy. What we are left with? We are left with MH1 plus capital Q is equal to what, my dear? MH2 plus W, right? Right now, yes or no, bacha party? Yes or no? Of course we can, right? So I can send, see, I'll send over here, that is mass common H1 minus S2, and here I'll send, my dear, W minus Q, right? Had you got it, this one? So my dear, now you know you have equation, that is what? M H1 minus H2 is equal to W minus Q, right? And you know that, my dear, you know that, what do you know, that your heat is what, my dear? Negative, that is rejection, na? It is rejection, right? So my dear, see, mass flow rate is given in the question, that is none other than, we have to calculate mass flow rate, right? H1. So you can write H1, that is what, my dear? Cp T1, Cp T2. Cp will be common, so I can write T1 minus T2. That will be equal to what, bacha? W. Wait, I can write over here. It should be MCP T1 minus T2, and it should be what, my dear? W. That W is given, and that is what, my dear? 4.6 megawatt. That we can convert it into kilowatt. So it should be what, my dear? 4.6 into 10 raised to power 3 minus of minus, because it is escaping means rejection, that is 300 minus 300, right? Right, my dear? My dear, and you know that Cp will be what, bacha? What will be the Cp's value? Cp का value क्या होगा? It should be 1. It is given. It is given in the question, right? ये क्या है? 1000 जूल में दिया हुआ है, right? But you can convert it into kilojoule. So you have to divide, multiply by 10 raised to power minus 3. That will be what? 1. Okay. So it should be mass. We have to find out 1. T1 is what, my dear? 1100. T2 is given, that is 400, right? 4.6 into 10 raised to power 3 plus 300, right? From here, my dear, you'll get M, and your M will come around. कितना आएगा बच्चा पार्टी? Your M will be 7 kg per second. कितना? It is how much, बच्चा? It is 7 kg per second. It's a very simple question based on what? Steady flow energy equation. It is based on what, my dear? Steady flow energy equation application part, and we have done the application of this steady flow energy equation on turbine. किस में अप्लाई किया था? टर्बाइन में अप्लाई किया था. Similarly, we can apply for compressor, we can apply for nozzle, we can apply for diffuser, we can apply for throttling, right? So we are this kind of thing we have already done, and the lectures are available. The lectures are available in the channel itself. Okay, I hope you got it, bacha party. Okay, so now my dear, now we'll go ahead और आगे चलेंगे, ठीक है? So guys, see, so this is steady flow energy equation. Now the another question, see, my dear, the pressure ratio across a gas turbine for air specific heat at constant pressure, and Cp is given, that is what? 1040 joule per kg Kelvin. Okay, this time joule again. Okay, and the ratio of specific heats, that is gamma, is given 1.4. Is it 10? Is it 10? Pressure ratio is what, my dear? 10. If the inlet temperature to the turbine is 1200 Kelvin and isentropic efficiency is 0.9, gas turbine at the gas temperature at the turbine exit will be. I just see. Now I'll draw, isentropic efficiency. So I want to let you know. Let me draw the curve. It is isentropic expansion. You know that, right? It is your isentropic. It is your actual. 1, this is 2s, supposed to be this is 2, right? This is your 2. First of all, I want to tell you, isentropic efficiency means what? For turbine. Isentropic efficiency for turbine, because they have mentioned turbine right now. Yes, bacha party, listen to me very carefully. So if it is isentropic efficiency, and if isentropic efficiency will be what, bacha? It should be none other than what? H1 minus H2, that is actual drop in enthalpy, to the actual ideal drop in enthalpy, because ideal drop enthalpy will be more because it's an ideal expansion, right? So definitely the change or the drop in enthalpy will be quite high in the isentropic expansion as compared to the actual expansion. Okay, so my dear, this one, right? If I convert this terms of CP, so CP will get cancelled from upper and lower side. What we are left with? We are left with this one. We don't know T2, we don't know T2s, and we have to find out. हमें क्या find out करना है बच्चा? We have to find out actual temperature of the gas at the exit of turbine, right? So my dear, you know that this is reversible adiabatic expansion. That means what? The process has been happened with this one. PV raised to power gamma is equal to C. If it is so, my dear, I can write. What I can write, bacha? I can write T1 upon T2s is equal to P1 upon P2s raised to power gamma minus 1 upon gamma. Right? Yes or no? My dear, you know that T1 is given. T1 is given, right? That is 1200. T2s. P1 by P2s is given, that is none other than, bacha, how much? 10. Pressure ratio across the gas turbine, it is already given, that is 10. Right? So I can put the value 10. And it should be 1.4 gamma, so I'll get 0.4 divided by 1.4. From here I'll get T2s. Guys, is it visible or not? Please tell me. Okay, it's not visible, right? Okay, it is here. I want to tell you, my dear, I want to tell you that is this 10 raised to power 0.4 divided by 1.4 only. T2s, what you get, my dear? T2s कितना जाएगा बच्चा? Your T2s will be how much? Your T2s कितना आ रहा है बच्चा party? It is around, let me check, 621.53. 621.53. It is 621.53 Kelvin. Okay, I hope it's clear to you. Okay, now guys, still our question has not been over. We have to calculate. Now we'll put the values. Eta of turbine is given, that is eta of turbine, that is none other than what, bacha? T1 minus T2 divided by T1 minus T2s. My dear, it is 0.9. T1 is 1200 minus T2 we have to find out. This is T1, that is again 1200, and T2s we got it, that is 621.5, right? So my dear, from here you will get T2, and T2 will be fine, my dear. कितना आ रहा है? It is 679. It is 679 point. How much, bacha? Yes. It should be 679.38. Okay, and this will be your answer. This will be your answer. ये आपका आंसर होगा बच्चा. Okay, yes, I hope you got it, बच्चा party. So here I go for next one. चलें आगे. Can I go for next? Okay, my dear. So here I go for next. These all are the previous year question that has been came into the GATE examination. 1 kg of an ideal gas constant is given, that is R is equal to 400 joule per kg Kelvin. Okay, specific heat at constant volume CV is given at 1 bar and 300 Kelvin is contained in a sealed rigid cylinder. Okay, during an adiabatic process, very important. Adiabatic means Q is equal to 0. Sorry, delta Q is equal to 0. 100 kilojoule of work is done on the system. Done on is very important, because this work done is going to be an input, or we can say negative system by stirrer, the increase in entropy of the adiabatic system. My dear, increase in entropy. What we have to calculate? We have to calculate, bacha party, that is entropy, right? What do we have to calculate? We have to calculate entropy. Very good. So my dear, we are going to calculate the what? Entropy. So my dear, see here. Now you know that it is adiabatic. So first of all, because you know what should be the delta S? Delta S should be what, my dear? क्या होगा बच्चा? It should be none other than what? CV ln T2 by T1 R ln V2 by V1, right? CV ln of T2 by T1 plus R ln of V2 by V1, right? Right, bacha party. But here you can see that contains specific heat at constant volume is contained in a rigid cylinder. If it is rigid, my dear, then where V1 is equal to V2, there should be no change in the volume. So my dear, I can say this term will get 1 and ln of 1 is nothing but what, my dear? 0. So this whole term will get cancelled out, right, bacha? So if it is the whole term is get cancelled out, my dear, what will we get? What we are left with? We are left with only CV ln of T2 by T1. What bacha? It is T2 by T1. Now we have each and everything, but still we are missing. Still we don't have what, bacha? Still we don't have what? It is specific. So you have to apply mass over here. यहाँ पे अगर आप mass लगा देंगे तो it will become, you can multiply it by mass. So here you can put mass. So here you can put mass. Okay. So my dear, we don't know T2, but if I go for the first law, that is dq is equal to du plus dw, my dear, you know that this is what? Adiabatic. Adiabatic means change in heat will be 0, right? That means, my dear, what I am getting, du is equal to minus dw, right? And you know that we w is what? Minus 100 kilojoule. So my dear, I'll get du is equal to what? 100, right? And you know that du is equal to बच्चा mcv dt. What क्या होता है? mcv dt होता है, right? So what I'll do, I will just use this formula like this. mcv dt means t2 minus t1 is equal to plus 100. m you know that 1. Let me check. m you know that 1, right? m क्या है यहाँ पे बच्चा? m is 1. Very good. You know that wait again, okay, yes, it's correct. You know that 1. CV is also 1, right? So you get T2. आपको क्या मिल जाएगा बच्चा? You will get T2, right? आपको क्या मिल जाएगा? T2 मिल जाएगा, right? So I just see. You will get T2. M हो गया CV. Okay, I have put it in the value now. It is 100. Sorry. M is 1. CV, my dear, you can see. CV 1000 joule है. We can convert it into kilojoule. So it should be what, my dear? 1. T2 we have to determine. T1 is given, that is none other than what, bacha? 300. It is 300 is equal to 1000. From here, my dear, you'll get T2. Your T2 will become how much, bacha? T2 will become how much? Your T2 will become 400 Kelvin. कितना आएगा बच्चा? It is 400 Kelvin. Okay. Now, my dear, if I apply the formula for delta S, what should be that delta S? You know that. क्या होता है बच्चा formula? Still we have seen this. अभी देखा ना हमने? Here it should be what? mcv ln of T2 by T1. So we can apply the same formula. That is mcv ln of T2 by T1. 1 mass is 1, right? 1 kg. And we have to calculate in joule per Kelvin. So we are going to put the values of specific heat at constant volume should be 1000. Okay. So it should be 1000 into ln. T2 we got 400. It is 300. Right, my dear? So from here you'll get delta S, and it will, the value of delta S will be bacha 287.68. 287.68 joule per Kelvin. Right? Yes, guys, you got it. Very good. Okay, if you got it, that's very good. Okay, So bacha party, this is what? This is nothing but what? This is all about the delta S, that is change in entropy. Okay. Now my dear, we'll go for next. Shall we go for next? Okay my dear, see here. Molar specific heat at constant volume of an ideal gas is equal to 2.5 times the universal gas constant. Okay. When the temperature increase by 100 Kelvin, the change in molar specific enthalpy in joule per mole will be, my dear. How we can find out? How we can find out? Yes, bacha party. How we can find out? Bacha party, be fast. My dear, C. How you can calculate? You know that delta H is nothing but what, my dear? Cp into delta T. Right? Rehayana, of course you can. Right? Now, my dear, it is given in the question Cv is equal to total volume of an ideal gas is equal to 2.5 times the universal gas constant. That is 2.5 into bar R. Right? So what I'll do, my dear? You know that Cp minus Cv is equal to R hota hai. Am I right? So my dear, from here I'll get what? I'll get Cp. This is bar R. So what it should be, बच्चा? क्या हो जाएगा? उधर जाएगा. So it should be 3.5 R. Yes or no? Guys, yes or no? Of course it should be, right? So I'll put the value and I'll get the answer. I'll put the value and get the answer. So my dear, you know that delta H is equal to Cp, that is 3.5 R into delta T. So my dear, you know that delta H, this 3.5 will be as it is, right ma? Delta R, that is value is given 8.314. Multiply by delta T. Here they have mentioned when the temperature increase by, it is nothing but delta T. Okay, so it should be what, bacha? 100. Now what should be the answer? Delta H will be what? 2909.9. Okay, it should be what, my dear? Joule per mole. Okay, very good. So this is all about what, my dear? This numerical is quite very simple. That only three that you have to understand. You have to utilize the equations that you have learned in the class. Okay. I hope समझ में आ रही होंगी चीजें सबको. Okay, guys. So here again I will go for next question. Okay. So here we have the next question. An ideal gas undergoes process from state 1, T1 given initial pressure and temperature is given, to the state 2, that is final pressure and temperature is given. The specific heat of the ideal gas R, Cp is this one, Cv is this one. The change in specific entropy of the ideal gas from state 1 to state 2 is क्या हो? अच्छा पार्टी. Yes, it's very simple numerical. That is the formula base. It is totally formula based, and you know that what should be, what it should be. Yes, bacha party. You know that you have two formulas, right, guys? Yes, no. Yes, of course. See, क्या फॉर्मूला है आपके पास में? हाँ जी. See, my dear, you have seen these formulas. You have formula that is none other than delta S is what, my dear? Cv ln of T2 by T1. पहला फॉर्मूला तो ये है R ln of what, my dear? V2 by V1. It is in terms of temperature and volume. You have another formula that is what, my dear? Cp ln of T2 by T1 minus R ln of what, bacha? P2 by P1. You have these two formulas, right? So simply because here they have mentioned pressure, So definitely the formula which we are going to utilize to solve this, that will be this one, right now. And they have asked in kilojoule per kg Kelvin, so there is no need to multiply it by mass, right? Because we are going to get this in already in kilojoule or joule per kg Kelvin. Okay, yes or no? Very good. So my dear, we are going to get this MCQ sessions फिलहाल right now it's little bit we have अभी थोड़ी दिन के लिए क्लोज है because right now we are focusing, it is also MCQ. ये MCQ ही है Sam. I want to discuss Sam, I want to tell you it is MCQ but it is totally based on the GATE examination. GATE के बेस पे है ये total. Okay, these questions are from GATE previous year questions. Okay, so my dear, if you know the formula, you know that delta S is equal to what बच्चा Cp ln of T2 by T1. चालू कर देंगे, don't worry Sam, we are going to launch it very soon. Cp and it should be what my dear, क्या होगा ये? Okay, so Cp, okay बच्चा पार्टी, so here Cp ln T2 by T1 is equal to minus R ln P2 by P1, right? So my dear, we are going to see, we can put the values, right? We can directly put the values, there is no issue in that, right? See my dear, I'll put the values. Cp is given in the question. Cp is how much? 1. I will put the value 1. Very good. Ln of T2 is how much? T2 is given 600. T1 is given 300. Okay. So 600 by 300 minus R. R you don't know. So my dear, see, it is 1 kilojoule per kg Kelvin. It is 0.7. So definitely Cp minus Cv is nothing but what, my dear? Cp minus Cv is nothing but what? R. So it should be what? R. That means what? R should be what, my dear? 0.3 kilojoule per kilomole Kelvin, right? I hope you got it. So my dear, it should be 0.3 ln of P2 is how much? P2 is how much? 500. P1 is 100. Right. So my dear, what you are going to get? What you are going to get? How much will be the answer? How much will be the answer? Definitely शुरू करेंगे Sam. Don't worry. Other examinations के लिए भी we can start. You don't worry. Okay. So what should be the correct answer? The answer will be, yes my dear, it should be 0.21. It is what? कितना आ रहा है? It is 0.21. Yes, anybody, can you tell me the unit? Sam, what should be the unit? It should be very easy, that is kilojoule per kg Kelvin. Okay, and this will be your delta S for this numerical. This is for 2 marks. कितने मार्क्स के लिए था ये 2 मार्क्स के लिए था. किसमें? गेट में. Okay, so guys, see again, I'll go ahead. आगे आगे, listen to me very carefully. A tank of volume 0.05 meter cube contains a mixture of saturated water. Very good question. This is a very good question. Mixture of saturated water and saturated steam at 200 degrees Celsius. The mass of liquid present is 8 kg. Entropy in kilojoule per kg Kelvin of the mixture is entropy. We have to calculate entropy. Okay, in kilojoule per kg of mixture is property at 200 degrees centigrade. They have given pressure at that particular temperature is given, Vf is given, that is what, my dear? Volume of liquid, volume of specific volume of gas, that is given, Pg. We have also given what, my dear? Entropy for wet region, entropy of liquid is also given, right? But we have to calculate what, my dear? We have to calculate the entropy of the mixture is what, my dear? Okay, we have to calculate the entropy change for the mixture. So my dear, how we begin it? कैसे शुरू करेंगे? Yes, बच्चा पार्टी. How we can begin? Guys, please be fast. Be fast, bacha party. How we can begin? So my dear, see. Capital V is nothing but volume of fluid plus volume of gases, that is vapor. My dear, you know that specific volume is nothing but what, my dear? Capital V F divided by mass of fluid, right now. So I can write capital VF is equal to what? Small vf multiplied by mass, right? Again, similarly for the vapor, I can write Vg mg, and it is given how much? Tank of volume, that is 0.05. Is it clear? Is it clear now? अगर ये समझ आ गई होगी तो you can get anything, right? ये अगर समझ आ गया होगा तो you can get anything. Okay, बच्चा पार्टी? I hope you got it. Here we go. So my dear, just put the values. Vf. So you can put the value. Vf is 0.00157. MF we have to find out. MF is given, I think. MF is given now. MF 8 है, given है. Mg we have to find out, right? Mg हमें find out करना है बच्चा पार्टी. Okay. So here we go. Here we go, my dear. So mass of fluid, that is given 0.01157, right? 0.01157, okay, multiplied by 8 plus Vg. Vg should be what, my dear? 0.12736. Wait, 0.12736 into mass of vapor is equal to what, bacha? 0.05. So from here you will get mass of vapor and that will come around. कितना आ रहा है बच्चा? वो आपका आ जाएगा 0.32 kg. It is how much? 0.32 kg. Okay. कितना आ गया बच्चा? It is 0.32 kg. Very good. It is 0.32 kg. If it is 0.32 kg, you know that dryness fraction is what, my dear? Mass of steam, that will be divided by what? Mass of steam plus mass of what, bacha? Liquid. Arey हाँ या ना? Of course, it should be. Very good. Very good. You got it? Very good. Okay, my dear. See. Mass of liquid means what, bacha? Mass of fluid, right? So mass of gases, that is nothing but 0.32. Arey हाँ या ना? It is 0.32 divided by 0.32 plus 8. What it should be? ये कितना आ रहा है? It is how much? कितना आ रहा है? It will come 0.0385. 0.0385. कितना आ रहा है बच्चा? It is 0.0385. It is your dryness fraction. Now, my dear, you know that entropy. Entropy will be what, my dear? SF plus dryness fraction into SFG, right? SF is given in the question and that is none other than what, macha? 2.3309. So 2.3309 plus. Why we are calculating the dryness fraction? Why we are interested in dryness fraction? Because I have formula, so I can easily calculate the entropy for the mixture, right? 0.0385, and I'll put the value of this, and that is nothing but what, my dear? 4.1014. 4.1014. I'll get the answer, and your answer will be, my dear. Let me check whether it is visible or not. It's visible. No, it could be Vamshi Krishna. No. Yes, you can ask your doubt. Vamshi Krishna, it should not be. It should not be 8. What they have said? Tank of volume 0.005, right now. So that means volume of fluid plus volume of vapor will be equal to what? V. And that V is equal to what, my dear? 0.05. But what I have done, this capital VF per unit of what, my dear? Fluid mass will be what? Specific volume. So I have split it into specific volume terms, and then I come to here. Okay, I have put the values and I have calculated. You can ask your doubt. Yes, Vamshi Krishna, if you have any doubts, please let me know. So what should be the answer, my dear? It is 2.488 kilojoule per kg. It is 2.4888 kilojoule per kg. Very good. Vamshi Krishna, I hope you got it, my dear. Again, I repeat once again. See, they have given the total volume. So total volume will be what, my dear? Volume of fluid plus volume of vapor. I have done the same thing. Now volume of fluid I have split it into, in terms of specific volume I have split it. That is specific volume multiplied by mass. That will be nothing but total volume of the fluid. So I have put it that in terms of this one. And then, my dear, I have put the values. Those who are given in the table. VF 0.01157. MF, they have already said 8 kg. See, mass of liquid is already 8 kg they have said. Right now. So I simply that put at the value and I have calculated mg. Then, my dear, I have calculated Reynolds fraction. Now I calculated entropy for mixture. Okay, you got it. That's very good. So, my dear, see, again I'll go for next. Now see, steam flows through a nozzle at mass flow rate mass 0.1 kg per second with a heat loss of 5 kilowatt. The enthalpies at inlet and exit are 2500 kilojoule per kg and 2530 kilojoule per kg. Enthalpies at inlet and exit they have mentioned respectively. Assuming negligible velocity at inlet, that is velocity at inlet will be 0. Okay, and velocity C2, that is at the exit, will be what will you use, my dear? It is what? Nozzle. We are going to use what, my dear? Steady flow energy equation. What we are going to use? Steady flow energy equation. And that is what, my dear? It is what? H1 plus V1 square by 2 plus GZ1 plus what, my dear? It is what? Mass. It is capital Q is equal to S2 plus what, bacha? Plus GZ2 mass flow rate plus W. Right now, my dear, see, ये उड़ जाएगा. This gone. This is also gone. Right? V2 is there, but this is also gone. Right? The atom will be same. Right, bacha party? I hope you got it. Okay, very good. So, my dear, now what I'll do? Very good. Very good afternoon, Dhiraj Rode. You are most welcome in the session. Now, my dear, listen to me very carefully. Now, what I'll do? Key that we have formula, right? This one. Okay. Now, my dear, listen to me very carefully. Q is given. Q is what? Minus 5 kilowatt, right? And you know that work done in the nozzle is what? 0. So, my dear, we have cancelled it out. Right now, my dear, you know that it is already given in kilojoule per kg, right? It is in kilojoule per kg. So what I'll do, wait, if it is in kilojoule per kg, you can divide it by, so it will also become in kilojoule per kg. So what I'll do, I will not multiply by the enthalpy by mass. What I'll do, I will divide the Q and I will make it small q, right? I'll replace this Q by small q. Okay. I hope you're getting, my dear. I hope you got it. Very good. So see here. Dekho dhyan se. What I'll do? I'll go to the next slide, my dear. So what I'll do? H1 plus capital Q divided by mass is equal to what, my dear? S2 plus V2 square by 2. Right? Yes or no, bacha party? I hope you got it. Very good. 316.22 aa raha hai. Let me check. No, it's not correct. It's not correct. You have done mistake, my dear. Okay. Now, one thing that you have to observe. Now, one thing I think you have done the mistake over here. My dear, see. These are in what? Kilojoule. Wait, huh? These are in kilojoule per kg, right? In the question, it is in kilojoule per kg, na? But, my dear, this kinetic energy is what in joule per kg. So what I have to do? I have to divide it by 1000. So now it will become 2000, right? So it will become kilojoule per kg now. H1, it is given in the question, and it is none other than how much? 2500. So I have put at this value 2500. And my dear C, again I'll want to tell you, heat loss means heat rejection. That is what? Minus what, my dear? Minus 5 divided by 0.1. I have taken kilojoule per kg. It is 23 something, right? 2350, right? Plus V2 that we have to determine by 2000, right? So my dear, you are going to get V2 from here, and your V2 will come around 447.21. 447.21. I hope you got it. Yes, bacha party, it is what? 447.21 meter per second. I hope you got it, bacha party. Okay. Yes. Anybody have any doubts? Please let me know and be fast. Dhanraj, Vamshi Krishna. Guys, you have any doubts? Then please let me know. If you have any kind of doubt, you can ask. Okay. So shall I go ahead? Okay, my dear. Here I go. The next question. Here I came. Here it is the next question. Air is held inside a non-insulated cylinder using a piston, mass M25 kg and area 100 centimeters square. Okay, and the stoppers of negligible area as shown in the figure. The initial pressure Pi and temperature Ti of air inside the cylinder. Okay, it is given. You can see this. Are 200 kilopascal and 400 degrees centigrade respectively. The ambient pressure is P infinity and temperature T infinity are 100 kilopascal and 27 degrees centigrade. Okay, respectively. The temperature of air inside the cylinder at which the piston will begin to move. Just piston move karega, start hona. Move nahi ho raha. It will start. Means there should be at equilibrium. That the piston will be at equilibrium exactly. Right now, guys, yes or no? Bacha party, very good. They'll start the moving. Piston will start moving means what, my dear? That is the piston will be at equilibrium. Hana? Yes or no? Very good. Very good, my dear. See, my dear. I'll tell you. I want to tell you. See, listen to me very carefully. Listen to me very carefully, my dear. Okay. ध्यान से देखना बच्चा. Can I explain? Okay, so here. Hi, you are most welcome, Pavitra. Now listen to me. Piston will start moving means what, my dear? See, this is your piston. Now listen to me, this thing. You know that here they have maintained stoppers. This one. These are what? Stoppers, na? ये क्या है? Stoppers लगे हुए. So the same stoppers I am drawing over here, right? This is the initial condition, right now. But obvious things there. So definitely the reaction will be there from these two stoppers to this piston because piston is moving to upward condition right now. Yes or no? But my dear, when just piston will start to move downwards, what will happen? It will just start to move down. That means the forces will get balanced, and that means what, my dear? There is no need of reaction from that stoppers, right? Yes or no? Very good. And this will load act downward. That is W. Yes or no? Very good. That is W is acting. Right, bacha party? I hope you got it. So my dear, see. Initially, the pressure will be Pi and Ti, right? If you have heated, again you are supplying heat, the pressure will rise. And it will what? It will touch the stopper, and my dear, again the heat transfer will take place and piston will start to move down. So we have to find out the temperature of the air inside the cylinder at which the piston will start moving. जहां से बिल्कुल शुरू करेगा. So at that instant we have to find out. Okay, I hope you got it, bacha party. Yes, very good. So my dear, see, I'll go. Can I, bacha party? Can I go ahead? So here, see, my dear. ध्यान से देखिएगा. Okay, listen to me very carefully. Listen to me very carefully. First of all, we have to find out the P naught. कि इसमें आपने वो तो कर लिया, right? But we have to find out P2. P2 will be what, right? P2 क्या होगा? See my dear. Ti inside the cylinder, the ambient pressure P infinity and the temperature is T infinity respectively. Very sorry. Very sorry. So guys see, my dear. Now we're going to calculate P2. So P2, how we can calculate P2? Yes, anybody have any idea? Guys, be fast, बच्चा party. But it should be, एक तो जो 100 किलो पास्कल लग रहा है एटमोस्फियर, राइट ना? अरे बच्चा पार्टी, यस, वेरी गुड, yes, very good. So it should be what, 100, right, plus what my dear, W by A, यही होगा, राइट? इनिशियल प्रेशर प्लस अगेन जो आपने लोड के कारण लगा वो प्रेशर, राइट ना? यस और नो बच्चा पार्टी? वेरी गुड, एवरीबॉडी ओके गाइस, डू यू फॉलो? इफ यू फॉलो देन आई वांट टू टेल यू, सी क्या हो जाएगा? वेरी गुड, it should be very good. That is what my dear, it will be 100 plus W is equal to mg by A for area. So it should be 100. Mass is given, right? Mass is how much bacha? 25 kg. It is 25 kg into what my dear? 9.81 na? 9.81? Yes or no? It should be what my dear? 9.81, right? And you have to multiply it by what my dear? Pascal होगा ये. So we have to multiply it by 10 raised to power minus 3. So it will be in kilo pascal. यही multiply कर दिया. Area is what my dear? Area they have given. Let me check. Area, what is they have given? Area, that is 100 centimeter square. We have to convert it into meter square. So we have to multiply by 10 raised to power minus 4. And we are getting pressure P2. And that will be my dear 125 kilopascal. कितना? 125 kilopascal. Okay. If it is 125 kilopascal, my dear, right? Now, when the piston will start just start to moving down, at that time, my dear, at that time, the volume at that point, the volume inside the piston will remain same. That is, my dear, V1 is equal to V2 at the point where it will start moving down. So for a particular instant, the volume will remain same inside the cylinder, right now. So my dear, I can say that P1 by P2 is nothing but what, bacha? T1 by T2. Yes or no? Yes or no? Of course I can say. Of course I can say, my dear. Yes or no? P1 by P2 is equal to T1 by T2. My dear, you will put the value and get the answer. Put the value, get the answer. Right? So my dear, see. ये क्या है आपका? P1 is 200. P1 is 200. It is 125. T1 is how much, bacha? T1 is how much? T1, look at, check me. Let me check. 27. That is what? 27 plus 273. That is what? 300. No. This one, na? 400. 400 plus 273. That is 673. Sorry. It is 673 divided by T2. From here, my dear, you'll get T2. And आपका T2 आ जाएगा. T2 will come 420.62. 420.62 Kelvin. Right? And this will be the correct option. This will be the correct option. Okay? Yes, everybody. Everybody, yes. It is not, no, degree centigrade. Okay, you have to calculate in degree centigrade. So you can minus 420 minus 273. Correct. Vamsi Krishna, correct. Vamsi Krishna, you are correct, my dear. Okay. So now I'll go ahead. और आगे चलेंगे बच्चा. Here we go. Here we go, my dear. Okay. See here. The figure shows a heat engine. working between two reservoirs, the amount of heat Q2 rejected by the heat engine is drawn by heat pump HP. The heat pump receives the entire work output W of the heat engine. If the temperature T1 is greater than from T3 greater than from T2, then the relation between the efficiency eta of the heat engine and the coefficient of performance COP of the heat pump is. क्या पूछ रहा है? सी एक हीट इंजन है और एक हीट पंप है, and they are asking for the relationship between the COP and efficiency. So my dear, we have already I think there is no need to derive it. We have already learned in thermodynamics. That is what, my dear, COP of heat pump is equal to 1 plus COP of refrigerator is equal to 1 upon efficiency of heat engine. Right now, so definitely I can say what should be this one. Number 3 is correct. Guys, yes or no? Vamsi Krishna, had you got it? It's a direct answer. There should be a direct answer of this question. There's a direct answer for this question. Yes or no? Vamsi Krishna. Vamsi Krishna, had you got it? There is a direct. Very good. We have already learned this right now. So definitely the option will be number 3. Okay, now I'll go for next. Water is flowing at the rate of 1 kg per second through a system is heated using an electric heater, okay, such that the specific enthalpy of water is increased by 2.5 kilojoule per kg. Okay, specific entropy increased by 0.007 kilojoule per kg. The power input to the electric heater is 2.5 kilowatt. There is no other work or heat interaction between the system and surrounding. Assuming ambient temperature of 300 Kelvin, the irreversibility rate of the system in kilowatt. My dear, how we can calculate? Gauss-Tudela equation. Do you remember Gauss-Tudela equation? Vamsi Krishna. Krishna, do you remember that? Do you remember that? Yes, bacha. Yes, bacha party. Tell me. Do you remember? Yes, please tell me. Very good. Very good. No, sir. Okay. I'll tell you. My dear, see. I want to tell you. There is, to calculate irreversibility. Irreversibility is nothing but what, my dear? Loss of available energy. Loss of available energy. Or it is sometimes also known as what, my dear? Increase in available energy. Unavailable energy. UAE. UAE means what? Unavailable energy. It is means what, my dear? It means unavailable energy. Krishna, remember, unavailable energy. Okay. So, my dear, the equation given by the Gauss-Tudela, that is what, my dear? T naught into delta S. Right now. So, my dear, here the delta S is given, but it is specific. It is per kg right now. So we want in kilojoule. So my dear, we have mass. So we can multiply. Delta S will be what, my dear? It should be 0.007 what? Kilojoule per Kelvin. Yes or no? Because mass is 1 now. So I have multiplied by 1. That means 0.007. It will remain same. Right? So my dear, I'll get I direct. That is, what is T naught? T naught is what, my dear? Surrounding temperature. It is surrounding temperature, and that is given in the question. 300 ambient. Ambient means surrounding, right? 300 into what, my dear? 0.007. So what will be the correct option, my dear? Kya hoga answer? What should be the option? 2.10 kilowatt? Yes or no? It should be 2.10 kilowatt. This will be your answer, and this will be your answer. Okay. This will be your answer. I hope you're getting, Krishna. Okay. So guys, we'll go for next. Okay, see. If 1 mole of S2 gas occupied a rigid container with a capacity of 1000 liter. 1000 liter means what, my dear? 1 meter cube. 1000 liter means what? 1 meter cube. And temperature is raised from 27 to 37. The change in pressure of the contained gas round off to 2 decimal places, assuming ideal gas behavior is, we have to find out pressure, my dear. Kya find out karna hai bacha? We have to find out pressure. So we can use simply what, my dear? Ideal gas equation. What we can simply use ideal gas equation, right? Am I right? Very good, very good. See, you know that. So we know that ideal gas equation, बच्चा क्या होती है? What is ideal gas equation? Ideal gas equation is nothing but what, my dear? P1 V1 is equal to, for this numerical, it should be what? nRT1. Yes or no? Yes or no, bacha? Very good. nRT1. So I'll calculate P1 is equal to nRT1 by V1. And here they have said n is equal to 1 mole. That is n is equal to 1. And the R value is given in the question, right? You can put the value. You can put the value over here. That is 1 into 8.314. T1 is given. T1 is 27. That is 273. That is 300. It is V1. V1 is what? 1 meter cube already given. So my dear, you will get P1. And P1 is come around. Kitna aa raha hai PM? P1 is how much? P1 will be around, my dear, 2494.2. 2494.2 Pascal. Okay, this is P1. Similarly, I can apply the equation for this one. P2 V2 is equal to nRT2. Right? Volume will remain same. Volume will not going to change. 1 mole of occupied rigid container. Rigid container, the volume means V1 is equal to V2. Rigid container means, right, bacha? So P2 will be, it's a very simple question, right? N1 8.314 37. 37 means how many Kelvin, dear? 37 plus 273, that is 273, and I think 310, right? कितना हो जाएगा बच्चा? ये 310 हो जाएगा. V21 कितना आ रहा है? P2, your P2 will become around P2 2577.34. 2577.34. 2577.34 Pascal. It is your P2. So what should be the change in pressure? That is delta P. That should be what? P2 minus P1. It will come around. कितना आ जाएगा बच्चा ये? Very good. 83.14. Very good, Vamsi Krishna. 83.14. I have written your answer as it is. Krishna, very good, dear. Very good. Okay, so this is a very simple question that is based on the ideal gas equation. So this kind of a question also, I think this is the question from, I think 2018 or something. 18 or 19 ka question hai. 19 ka, I think. Okay, we'll go for next. See, my dear, we have another question. A gas heated in duct as it flows over a resistance heater. Consider a 101 kilowatt electric heating system. The gas enters the heating section of the duct at 100 kilopascal and 27 degrees centigrade with the volume flow rate 15 meter cube per second. If the heat is lost from the gas, okay, that is negative, to the surrounding at the rate of 51 kilowatt, the exit temperature of the gas is what, my dear? We have to again find out exit temperature. Last time we have find out what, my dear? Final pressure, but this time we have to find out what, bacha? इस बार क्या find out करना है? We have to find out exit temperature. So we can easily find it out. We can easily find it out, right, bacha? Yes or no? Easily find out कर लेंगे इसको. W is given, Q is given, everything is given. You have to just simply apply the steady flow energy equation, right? So I just steady flow energy equation apply करूँगा. So what I'll get? MH1, because that kinetic and potential energy will get 0, and plus Q is equal to what, bacha? MH2 plus W. So M is nothing but what, bacha? CPT1 plus Q is equal to MCPT2 plus W, right? Yes or no? So my dear, M is given. M given है. M is कितना given है बच्चा? Let me check. Cp is given. Gas enters the section at the flow rate. Okay, flow rate is given. If the heat is lost from the 750 and the exit temperature, assume constant pressure, negligible in kinetic. Okay, kinetic energy and potential energy यहाँ पे neglect करने बोला था. Right now, so my dear, what should be the value of mass? Mass कैसे calculate करेंगे? Or it is given. Mass is 10 kg per second. 10 kg per second is given, right? No, it's not given. We have to calculate. We have to calculate. So we can calculate, my dear. Mass, we can calculate mass. That is what, my dear? P1 V1 divided by RT1 from this formula, right? You can get very good. Yes, it is not given, very good, it's not given, that's why I'm calculating, very good, that's what I'm calculating. Krishna, look at this, P1 given, V1 given, right? 100 into 10 raised to power 3, right now? Yes or no? Pascal में कर लेंगे बच्चा पार्टी. Okay, I hope you got it. So here my dear, pressure is given 100 kilopascal, so I'll convert it into Pascal. V1 is given, that is how much? V1 is how much given? Let me check. V1 is given how much? V1 is your 15 is given now. Volume flow rate, yes, this one 15. So it is 15. R is how much, bacha? R is 0.5. Very good. Okay, but I 0.5 is what? Kilojoule. So we have to convert it into what, my dear? We have to convert it into joule. Right now, किसमें convert करेंगे इसको? Joule में. So we can multiply 10 raised to power 3. T1 is given. T1 is what, my dear? 27. That is 300. Right? From here you will get M. And your M will be, my dear, 10 kg per second. Okay? 10, very good. You'll get M is equal to 10 kg per second. Very good, my dear. Now, see, my dear, we got M is equal to 10 kg per second. Right now, so you can put the value and get the answer. Right? CP is given in the question. CP is also given 1. Right? M is given. T1, you know that. Q is also given. Q is how much? That is heat is rejected. That means what? It is minus 51. Okay. And M is given. CP is given. T2. T2 we have to find out, right? T2 we have to find out. And W is given. W is how much? Here you can see. I have seen W is given. W is how much, bacha? 101. See. Kilowatt electric heating. Right now. So it should be, whether it should be positive, negative. Vamshi Krishna, please tell me what it should be. How we can took? It should be what? Minus 101, because you have supplied that much amount of electrical power to the heater. So definitely it should be what, my dear? It is an input. So definitely it should be negative, right? And we have to convert it into what, my dear? इसको किस में convert करेंगे? पूरे terms को watt में convert करेंगे. Okay? I hope it's clear to you. Now, my dear, I'll go ahead. See, अब आगे चलते हैं. आगे चलें. So बच्चा party, here we go. See here. So 10 into CP. CP is what, my dear? It is in kilojoule. We have to convert 1000, right? 1000. T1. T1 is 300, right now? T1, okay, done. Minus 51 into 10 raised to power 3, because it is in kilowatt, is equal to what, my dear? That is 10. CP is 1000. And again we have T2. T2 we have to find out. And my dear, it should be what? 101 into 10 raised to power 3. So from here you will get T2, and your T2 will come around, bacha. T2 how much? 305 Kelvin. 305 Kelvin. Very good. Very good, Krishna. It should be what? 305 Kelvin. And this will be your answer. This will be your correct answer, my dear. I hope you got it. Krishna, I hope you got it. Okay, here we go for next. Chale bacha party aage. So here we go. See, my dear. Air of mass 1 kg initially at 300 Kelvin and 10 bar, okay, is allowed. If anybody have any doubts on that last question, please ask me. Okay, initially at 300 Kelvin and 10 bar is allowed to expand isothermally. Isothermally means that is T1 is equal to T2. Temperatures will be equal till it reaches the pressure of 1 bar. Okay, as that is P2 is given. Assuming air as an ideal gas with the gas constant 0.287 kilojoule per kg Kelvin, the change in entropy of the air, they said that we have to calculate. They said we have to calculate what, my dear? क्या calculate करना है हमें? We have to calculate entropy, right? Change in entropy. Right now we have to calculate change in entropy, right, bacha? So we can easily calculate. Right? So see how to calculate. I'll tell you. You know that we have direct formula. Delta S is equal to what, my dear? क्या फॉर्मूला हमारे पास? It is Cp ln of T2 by T1 minus R ln of what, बच्चा? P2 by P1. right? But you know that this T2 by T1 is what, my dear? Same, so it should be get 0, right? So it should be what? Minus R ln what, my dear? P2 by P1. R is what? Minus R is what, my dear? 0.287. Ln of P2 is given. P2 is what? 1 bar. P1 is what, my dear? P1 is 10 bar. So what is value? Value कितनी आ रही है बच्चा? Its value will be what, my dear? It's P2 by P1. Now you do one thing. Just you can do one thing also. Don't worry. It is minus na. Minus. What you can do? You can write in this form. R ln P1 by P2. That will be better. So my dear, what you'll get? You are going to get 0.287 ln of P1. P1 is how much? It is 10 bar. P2 is what? 1 bar, right? So my dear, going to get answer, and delta S will be कितना आ रही बच्चा ये? What is the value of delta S? Yes, Krishna, what is the value of delta S? It is what, my dear? It is none other than 0.66084. 0.66084 kilojoule per kg Kelvin unit. Very good, Krishna. Very good. Very good. That is kilojoule per kg Kelvin, right? Now, my dear, I'll go for next one. एक और लेते हैं. Okay. Here, 1 kg of air initially at temperature of 1 to 7 degrees centigrade expands reversibly at constant pressure, that is P1 is equal to P2 until volume is double. Volume is क्या हो गया? Double. Okay. If the gas constant of air is this much, magnitude of work transfer. They are asking work transfer. It's very easy question, my dear. It's a very easy question. You can easily do it. Yes. Guys, please tell me what it should be. क्या होगा बच्चा ये? C. W is equal to P into V2 minus V1 हो जाएगा. Volume is changing na. But you know that if I write PV P2 V2 minus P1 V1 like this, what I'll get? What I can write? P2 V2 is nothing but what, my dear? MRT2. MR will be common. I can write MRT2 minus what, my dear? T1 na. Right? Volume is constant. If the volume is constant, bacha, if the volume is constant, can I write T2 by T1 is equal to V2 by V1? P1 is equal to P2. So I can write, my dear, T2 by T1 is equal to V2 by V1. So you know that V2 by V1, that is twice V1 divided by V1. It will get cancelled out. You are going to get T2 is equal to twice T1, right? So my dear, T2 will twice T1. That means what? 127 plus 273. That is 273 plus 27, 300, 400. So it should be what, my dear? 800, right? You can just put the value over here. So my dear, you are going to get work done. That is M. Mass is given. Mass is how much? Initially 1 kg. Okay, 1 kg we have taken. R is what? 0.287. Okay, it is in joule, but we have to calculate in 1 into 0.287. T2 is what? 800 minus 400. And my dear, your answer will be what? This is 400 multiplied by 0.287. So that will come around, bacha party. It should be around what? It should be 114.8. कितना आ रहा है बच्चा? It is very good, Vamsi Krishna, very good dear. 11.4.8. It should be what? Kilojoule. Okay, this will be our answer. Okay, now my dear, we'll took the another one. एक और लेते हैं. This for an ideal gas, constant pressure line and a constant volume line intersect at a point in the temperature T versus specific entropy S diagram Cp. The specific heat at constant pressure and Cv is the specific heat at constant volume. The ratio of the slopes of the constant pressure and constant volume lines at the point of intersection will be. हाँ जी बच्चा. Krishna, yes. Do you have any idea what is asking? क्या पूछ रहा है वो आपसे? Yes, what it is asking? It is asking the ratio of slope of constant pressure to constant volume. That is nothing but what, बच्चा? It is CV by CP. We have already derived. क्या होगा? It is what, my dear? CV by CP. क्या होता है? CV by CP होता है, right? ना DT by DS. DT by DS at what? The slopes of the constant pressure divided by DT by DS at constant volume is equal to what? This. So option number 4, direct answer. We have already derived this. Vamsi Krishna, we have already derived this. So guys, those who are new to this channel, that I want to let you know, daily at 3 p.m. Daily at 3 p.m. That is thermodynamic plus applied thermodynamic. That means RAC plus power plant engineering plus IC engine. Previous year gate question, fully solved. Gate question, previous year question for gate, fully solved in front of you. I will come with the another session. मैं रोज करता हूँ. I am coming with the daily live classes. So guys, please attend so that your previous year question solution for these subjects will be finished by in the session only, right? So today we have finished thermodynamics. Vamsi Krishna, tell your friends as well. आप अपने दोस्तों को भी बताएं so that they will get also benefited, right? And I want to tell you, I am coming daily. Okay, मैं रोज daily live आता हूँ. Okay, so guys, what you have to do, you have to come and you have to take the benefit out of this session so that your preparation will be get better and better, right? Because without PYQ solution, your preparation is like a human body without heart, right? So guys, we'll see you in the next session then. Thank you so much for attending the session and for your patience. I will see you in the next session. And my dear, if you are new to this channel, then please do hit like, share and subscribe the channel so that you will get latest notification from us regarding any live class. Whenever I will come live, you will get a latest notification regarding that live class. Okay, so thank you guys, thank you so much. We'll see you in the next session. And one more thing that I want to say, please stay at home, stay safe, stay online with the testbook.com.